Hello, my name is Vishnu Gosai, and this is my video lab report for Lab 1 for the class Physics 2211, taught by instructor Dr. Flavio Fenton. Now, to introduce the lab, the focus was to observe the motion of an object moving at the same speed without changing direction, and the goal was to understand what physical principles were at work commanding the object's motion. Now, the object I chose was a cylindrical water bottle, and to achieve a constant velocity or relatively constant velocity, I pushed the water bottle and then took a video of its motion after the initial force was applied. Now, I think that if we apply Newton's momentum principle to the water bottle, it will move at an almost constant velocity after the initial force is applied. However, it will be an almost constant velocity since the net force is almost zero due to the fact that the force of friction is what is causing the cylindrical water bottle to actually roll. However, this force is very small due to the fact that there's very little contact with the surface since it is a cylinder. Now, the main principle at work here is Newton's momentum principle, which can be written as F net equals delta P over delta T, or change in momentum over change in time. Now, if we algebraically manipulate this equation, we can get the final velocity equals the initial velocity plus F net times delta T divided by mass. And then if we plug in this newfound velocity into the position equation, final position equals initial position plus final velocity times delta T, we can actually predict the final position of an object, keyword being that if the force is almost constant. Now, and if the force is almost constant, we can find what the average velocity is in this case, which would be V final plus V initial divided by 2. And this average velocity equation will be important later in the glow script setup. Now, here is the tracker setup. For my tracker setup, I put the origin point at the starting point of the water bottle in the video. And if you look in the bottom right corner, you could see the blue line. I put it from the 57 centimeter tick mark to the 62 centimeter tick mark on the tape measure I put beneath the water bottle's path to give the tracker a sense of scale. And here are the results from the tracker. We could see that the final position of the water bottle was about 0.12 meters displacement from the initial position. And looking at the trend line from the velocities calculated from the position versus time graph, we could see that it was an almost constant velocity. However, there's much deviation due to probably human error or friction, which will be further discussed later. And here's the glow script code. We can see here that we have the velocity equation from earlier, as well as the position equation. And here I used the V average that I calculated from the actual data as a constant velocity to substitute in for the position equation. And here are the model results, where the final position is about 0.38 meter displacement using the calculated V average from the actual results. Now, looking at these two, we can see that the velocity was not constant for the actual data, since there's probably human error in placing the tick marks in the tracker equation for the frames, and also by the fact that the force acting on the water bottle is not actually net zero. There's a force of friction acting on the water bottle and air resistance as well, causing the water bottle to slow down over a period of time. And we could see all these things culminate into the final positions being different for the two of them. Thank you.